We are working on the bit by bit project from the YByte Python curriculum available at www.ybyte.in. Having seen bitwise and bitwise or and bitwise XOR, let's take a step back and just reflect on what we are doing, starting with some very interesting similarities in symbols. Remember when we discussed the AND operator, I mentioned that it's similar to intersection in sets. No surprise then that the symbol for intersection is in fact the same as the symbol for bitwise AND. Likewise, union is quite similar to OR and the symbols are the same. Symmetric difference is kind of like XOR and again the symbols are the same. So for example, if I have two set, let's say if I have a set, let's say 1, 2, 3, I did an union an intersection which is a 3, 4. I'll get a 3 because remember and is an intersection when it comes to sets. But if I were to do the same thing, let's say same operator but different type of operands, I will get 9 because that is a bitwise AND. Now this is really not surprising. We have seen in the past as well that look, the operator, I mean the result of the operation depends on the kind of data that we are operating on. Technical terms, this is called operator overloading. The same operator can mean different things in, let's say, different contexts. Likewise, let's say if we were to do a union, well, I'll end up with 1, 2, 3, 4 because it'll combine in either the value that's in either the sets, either of the two sets will be put in the new set. But if I were to do 43 and let's say the pipe operator, now this is a bitwise and bitwise and we know this is 191. If I did a symmetric difference between these two sets, I will get 1, 2, and 4 because remember in this or in this but not in both. So 1, 2, and 4 is is the right let's say set for this. But I could do 43, let's say 157, and that as you have seen gives us 182. So this is kind of like just a correction which I thought is quite interesting to highlight. Helps us also understand things better. Now the results of these operations are also actually quite interesting. We saw that when we did a bitwise AND between 43 and 157, just two numbers as an example, nothing special about them, but just selecting them. We got a 9 with OR, we got 191 with XOR, we got 182. Now clearly they are doing something quite different from let's say operators like plus minus, which we are more used to. And this is happening because fundamentally the operations is based on let's say binary representations. In fact, we can create some very very interesting let's say functions based on these operators. But that's for a later time. I want to just leave you with some food for thought. What do you think will be, for example, 43 and 43, 43 or 43, or let's say 43 XOR 43? In general, any number bitwise and with itself. Let's just see this in action. I'll let you think about this. Let's say I do 220. So let's just take 43 maybe. 43 and 43. Well, that is 43. 43 or 43. That is also 43. But if I did 43 XOR, let's say 43, that is a 0. Now think about this. Why do you think this is happening? Happy to discuss. But this relates back to the basic definition of AND, OR, and XOR. In fact, you can take any number XOR with itself. Let's say I do 231. Notice this is less than 255, so still an 8-bit number. If I did an XOR with itself, I will get a 0. Whereas if I did an AND on an OR, I will get back the same number. So, think about why this is happening. Quite actually interesting. Now, on that note, we previously built a missing operators project where we use the familiar arithmetic operators plus, minus, and so on. But it could be quite an interesting challenge to build a missing operators project with these operators. Solving that will be quite hard, in fact, because one will have to be quite familiar with the binary representations of numbers, and only then we can kind of guess what's going on. And if we add lots and lots of numbers, it's going to be very very challenging. So I think that's an interesting, let's say, enhancement to the missing operators project as well. We will come back in the next video to look at some very special cases. There are some very interesting cases here. What happens when I, let's say, take a number and let's say add it with a specific pattern, or it with a specific pattern, and let's say XOR it with a certain pattern, right? So those are, let's say, some kind of special cases. We will look at them in the next video because those are relevant to us when we build the LED patterns project that we are going to build. But I hope this discussion was interesting. It made you think a little bit and see some connections which make the whole learning, let's say, more holistic. At YByte, we learn programming in a systematic step-by-step manner and make our journey fun by applying concepts to activities. look at our website www.ybyte.in, because you will find many activities through which we learn Python programming. Take care. Thank you so much. Bye bye.